I'm going to get started. Welcome, it's 5:05. Welcome everyone to this evening's deliberative forum on artificial intelligence. How should we as individuals, as communities, and as policymakers engage with this new technology? My name is Graham Bullock, and I'm a professor in political science here at Davidson College. I'm also the faculty director of the Deliberative Citizenship Initiative, or DCI for short. And the DCI is really excited to be co-hosting tonight's event with Davidson College's Technology and Innovation Office, the Computer Science and Digital Studies departments, and the Bonner Scholars Program. I think we have several Bonner Scholars here tonight with us. We're also excited to be hosting our second forum that features an in-person panel, as well as opportunities for all of you to participate in conversations with one another, both here on campus at Davidson and also online. So we have a good number of people logging in, listening in via Zoom. So welcome everyone virtually and also to everyone here in person. Thank you for joining us. So before we get started, we'd like to ask that you complete a short survey that has been copied into the chat. So Lagan is one of our senior fellows and student co-convener. She's running Zoom for us, and she's going to copy some stuff for you guys into the chat. And then on the tables in front of you, there's a QR code, one that it says pre-survey. So don't turn it over, don't do the post-survey yet, do the pre-survey. And it's just a couple quick questions. And then we'll ask you to scan the reverse side afterwards, after the event. And these surveys help us design and improve these forums so we make them better each time. And so if you scan it, then pass it along to the person next to you. So we've also, for you friends online, we're enabling live auto transcription for this event. So if you would like to enable this on your end, click the More button and then select Show Subtitles. Please note that captions are automated, so they may not always be accurate. Before we begin, we'd like to share a little bit about the DCI, which you can learn more about on our website, deliberativecitizenship.org. The purpose of the DCI is to create opportunities like this for Davidson students, faculty, staff, community members, and alumni to engage with one another on really important but contentious topics facing both our community and our larger society. And how we should engage with emerging technologies like AI that have the potential to transform, improve, and disrupt many aspects of our lives is certainly one of these topics. As well-meaning and well-informed people can differ about the benefits and drawbacks of such technologies. So to help us better understand and explore these diverse perspectives, we've paired a fantastic panel of experts with an opportunity for all of you to talk through these questions with one another in our small groups. We have over 20 trained DCI facilitators ready to facilitate these discussions and lead you through the deliberation guide that we shared with you previously and is available on the tables in front of you and in the many emails that I sent previously, and Dr. Kopik did as well. As you know, tonight's event is free of charge. The only thing we ask is that you join the small group discussions after the panel. These discussions are the primary purpose of the DCI and this event. The panel is designed to catalyze your conversations with your fellow citizens. They are a great opportunity for you to both express your own ideas and questions while listening to those of others in your group. We are live streaming this event via YouTube through Zoom so that those of you will be able to seamlessly move from listening to the panel to engaging with fellow participants on Zoom in breakout rooms. If you have any trouble with the Zoom feed, we can share the YouTube link via chat, but hopefully it'll all work smoothly. Just be in communication with Lagan if you have any trouble. In the interest of maximizing our time for our conversation, we're not going to give extensive introductions to our panelists. Suffice to say, they have backgrounds and experiences and expertise that are highly relevant to our subject today. And you can read about their expertise on the bios that are on your tables in front of you. Damian Williams is an assistant professor at UNC Charlotte in philosophy and data science, who studies AI's potential for both bias and consciousness. Lauren Kahn is a senior research analyst at Georgetown University's Center for Security and Emerging Technologies, CSET, and is focused on national security applications of artificial intelligence. And Richard Boyd is a tech entrepreneur who has developed AI and machine learning applications in the context of gaming, entertainment, healthcare, education, and many more fields. And our moderator tonight is Dr. Sarah Kopik, the DCI's assistant director, who also happens to be deeply interested in artificial intelligence as a philosopher of language. She is an affiliate researcher with UNC's AI project and is teaching a course this semester on AI. And I think some of her students are here tonight with us. So she is especially well suited to start off our conversation today with our panel of experts. So Dr. Kopik, please.
Thank you so much, Graham, and many thanks to all of you for being here today and joining us to talk about this really important topic. So I'd like to extend a thank you to our panelists as well for joining us here today. And I'd like to kick it off with our first kind of big open-ended question. What are your biggest hopes for AI's potential impact? And on the other side, what are your biggest concerns and fears? And Damien, if you'd like to start us off, please do.
Hello, everyone. Thank you all again for being here. Really appreciate you all joining us for this conversation. In terms of some of my biggest hopes for what artificial intelligence might be able to do, I think a lot about the kinds of patterns that AI has been shown to be very good at finding and been able to both replicate and iterate on. It's helped us to identify different types of medicine that might be able to be more carefully targeted to specific individuals. It's helped us to be able to find gene therapies. It's helped us to be able to find cancers and to in general just do a lot of things in a medical field that we would not have been able to do with just humans alone, or at least nowhere near as quickly and robustly. So I do think that there's a large potential for certain types of applications that can show us things and show us patterns and show us ways of understanding the world, help us draw connections that we otherwise might not have been able to do without this technology. In that same vein, I worry a lot about the kinds of patterns that sometimes AI draws and iterates on its own. As we know, and as we're going to talk about a lot for the rest of this evening, I'm sure, a lot of the things that AI does is because of what it's been trained on and what humans have told it to do. And a lot of times the kinds of things that humans have told us to do or trained it upon have harmful biases in them. And so the patterns that get reiterated, the patterns that get exacerbated are often very harmful patterns. And so sometimes we see in that same field, for instance, in medicine, we see recommendations or we see clarifications that unfortunately seem to riff on the kinds of harmful racialized or gendered biases that oftentimes already exist in human medicine. And so those kinds of things left unchecked have the potential to be extraordinarily impactful in an even kind of a deadly and life-altering way for human beings. And I think that too often still we're not fully considering the realms and the ranges of the ways that that kind of thing can happen before implementing these systems in lots of aspects of everyday life.
Thanks. Yeah, you've touched on some important themes that I think we will return to. Lauren.
Awesome. Thank you. Yeah, it's great to be here. And given my background, I'm going to kind of constrain the question to focus a little bit on the military and national security domain. I would say my biggest, hopes is that, it ultimately makes the world a safer place, that it helps the United States and its allies and partners use these kinds of technologies to extend their national security and state interests for the betterment, hopefully, overall. On the same side, though, that means that there are inherent risks to these systems, as Damien pointed out, and I'm sure my co-panelists and I will talk about later on, but that can be exacerbated, especially when you introduce them into these very high-risk, complicated systems when you're looking at the state level. I'm going to, with Sarah's blessing, hopefully reframe the question a little bit. for this particular domain, but the debate less so is about right now in this space, whether it's good or bad. AI is seen as inevitability, almost a technology that states must acquire to keep up. And it's a matter of by pacing how states should approach this. It's often framed as a dichotomy between moving quickly so that you're able to compete effectively to ensure your security as well as those of your allies and partners, versus how do you ensure that you do so safely and responsibly as well. And while that's sometimes made to be a false dichotomy, I think that you can do both of them at the same time. You can do things with responsible speed is sometimes the third term that's used, but I think that's very, very important to acknowledge that there needs to be a trade-off made between moving quickly to make sure that you're ultimately able to take advantage of these capabilities and make sure that you're leveraging them effectively, but also that you're not creating things that are, introduce new novel risks or exacerbate potential for accidents, miscalculation, conflict, et cetera. Thank you.
Thanks so much, Lauren. Richard.
All right. Well, I guess as the oldest person on this panel who's been at this for 33 years, I asked for a rocking chair, by the way, but they still put me in just a regular chair. My perspective is a little different. I want to start with a quick question. How many of you are actual practitioners, meaning you're developing AI applications? All right. How many of you are using AI applications? All right, I want to see everybody's hand go up now, right? But the first statement I want to make, and I might make a couple of provocative statements that hopefully will get us all arguing afterwards, but ChatGPT, that bump in the night from November 30th, 2022, that altered everything and has us having these gatherings like we're having now, that is one piece of AI. It's not all of it. And in my view, it's not even the most important part of it. So we can argue or whatever about that later. There's lots of pieces to this. And I've been at this, like I said, for a while. Started out at entertainment and computer gaming in the 90s, my Peter Pan years, as I call them. And back then, AI was just anything that wasn't working yet. The minute it started working, we just called it code. And that's all it was. It was finite state machines. It was behavior trees. It was making convincing characters, convincing environments that for all of us to play in. It got a lot more serious about 2009. So that was my bump in the night when I first encountered machine learning. And the reason I'm getting to your question here, which is, what am I concerned about and what I think the great opportunities are and what am I concerned about? It all comes down to this two-word term, utility function. So have all of you, raise your hand if you've heard of that term before. All right. So this is a very important concept for us to discuss even tonight. It all comes down to what are you designing for? What are the goals of this system? And machine learning is only as good as its utility function, and then only as good as the things that it's fed to learn from. Just like if you're trying to raise a child and make them a doctor or make them successful in school or a good citizen or whatever as your utility function, then it's like what inputs do they get to head towards that? So what's the utility function for social media? Very powerful technology, network computing. What is it, anybody? Monetizing human attention. That's all it is. That's its goal, not bringing us together, not solving for truth or anything like that. So the concerns I have are when we don't have good utility functions and we don't really put a lot of thought into that, you get sometimes, what is it that Rumsfeld said, the unknown unknowns? You get the unintended consequences, or the intended consequences don't always happen, but the unintended consequences always do. Right down. We can argue about that later too. But yeah, I think there's a great opportunity today to design from the beginning good utility functions based on human values. And of course, the question then is whose human values? But we can design better cities, better countries. We can populate the stars. We can cure cancer, as Damien was talking about. That's the hope for it. The sort of downside of it is, if you don't have good utility functions and you don't have good data that's biased data and you give it too much control, there's a large set of very bad things that happen from Skynet in your world. And I worked on some James Cameron things, so I've listened to him talk about that quite a bit, to just some mild things like slightly misinformed populations going out and making big decisions, or deliberately misinformed people. So I think in this year, we really have to be concerned about that. So there's like a good handful of things I'm very hopeful for. There's a large set of things where if this goes off the rails, it can go really badly. But it's not just ChatGPT. There's knowledge graphs, there's finite state machines, there's other elements of this that are coming into play.
So all three of you have touched on some great potential for good and also some great potential for risk, whether it has to do with social bias, whether it has to do with military threats. And Richard, what you just mentioned actually leads me to my first question for Damien. And after that, I'd like to invite some kind of crosstalk before we move on to the next question. So Damien, I'd like you to kick us off with the following. So given your background in philosophy and AI, how do you see AI potentially aligning with our values? And on the other hand, how do you see AI potentially failing to align with our values and running counter to them? In what context does this trouble you the most? And do you see reasons for hope?
So this is a very important question, and it gets to a little bit of the context of one of Richard's framings in his answer as well. Whose values? Which values are we talking about? When we say we want alignment, when we say that we want AI to align with human values and that we're working on alignment problems, it's a large, it's a big, very open phrase that gets bandied about a lot within the AI circles these days, working on alignment problems. Which values are we trying to align with? Because at current, there's a case to be made that the values that are being aligned with are already human values. They're just bad values. The fact that it's not a good value doesn't make it not a value. The fact that it's dangerous, that it's harmful, that it's antisocial in many cases doesn't make it not a value. So the question becomes, which values are we seeking to align with? And that's the question fundamentally that so many people aren't asking. So when we ask, where do we see human values at play? I see values at play in every aspect of every AI technology that exists or ever has existed. Human values are a part fundamentally of every technology that humans make. Humans build systems, and we build our desires, our perspectives, our beliefs, our values into those systems. So the question becomes, since that's going to happen anyway, which ones do we want to build into them? In a conversation like this, I'm hoping that we're thinking about values like democracy, values like deliberation, values like cooperation, values like community, values like justice. But then we have to ask the question, what do we mean? Whose definition of justice? Whose definition of community? Whose definition of democracy? Because all of those questions are not just givens. We have perspectives on them, but those perspectives are culturally modulated, culturally mediated. They're based upon where we come from. At every stage of this, I see promise in the fact that more and more people are asking exactly these kinds of questions, the kinds of things that we're talking about here today. And I'm concerned because we're still not doing that kind of deep dive on the process of really excavating those questions out, of really unpacking the implications of those questions. Because it's only when we do that kind of further implication unpacking that we can start to see that this isn't going to be something where we can just build a checklist that says, yep, democracy's in there. Community, got it. Ethics, yes. We're going to have a process, a kind of recurrent, deliberative, continual, intentional process that we're going to have to keep coming back to. And we're going to have to build systems that can somehow keep coming back to that process as well. Systems that check themselves and that we can check. Once we can do that, once we start to think about that, then I think we can start to build the kinds of things where we're very clear about which values we want. We're very clear about what we mean when we say we want to build and align certain types of ways of being, ways of knowing into these systems that we're building. So that's where I see that kind of framework setting currently.
All right. Richard and Lauren, do you have thoughts where you agree or disagree with something that Damon's contributed?
Go, please.
Oh, no, I'm happy to jump in here because I get a very similar question often when talking about lethal autonomous weapon systems or killer robots, right? You get this question about, or even more broadly, you get this question about bias in systems that are used in national security contexts. And this is probably my first hot take of the night, but I think that, again, to Damien's point, you can't really completely eradicate bias from these systems that are inherently socio-technical systems, right? Even the best of the ability. And in some cases, you might not want to. You might want it biased towards something in particular. I think it's important to be aware of that bias, however, and to be cognizant of that. And I think it gets even more complicated, unfortunately, in the military sphere when there is somewhat, hopefully, a shared kind of interest among states, even those that are adversaries, to kind of create these systems that are, created safely or not necessarily biased, because that means a system that is not biased or, has bias that you're aware of is a system that works well. And military, surprisingly, are risk averse. So they do not want to implement systems that do not work well. And so hopefully that's a little bit of a calming effect there, that, these kinds of values aren't inherently unaligned in some of these systems, but at the same case, I think it means that we need to be aware that these systems will not be perfect.
Yeah, so there's a lot to unpack here. And as old guy, I'll go back and say that this problem all started the minute we started networking computation together, right? The minute we started, and we're 30 years now. Did you guys know that? It's been 30 years since we've had the graphical internet, but of course, ARPANET and the internet existed before that. And luckily, there wasn't any state or one company that organized that. Luckily, we allowed it to evolve from institutions like this. There were academic institutions whose utility function or goal was better knowledge and truth. And that's who networked all this intelligence together initially, because as we all know today, as we look back at how the internet was born, had a nation state, even the great United States of America, been involved in organizing it and designing it, they probably would have strangled it in the grave as soon as they understood what it was doing. Because again, we're seeing lots of implications of it. But this is my moment where I'll put in a plug for the People-Centered Internet. If you haven't heard of that, please look into that. I'm a member of that organization. It was created by Vint Cerf. Anybody heard of that? How many of you heard of the Clue Train Manifesto? Please write that down for you. Yes, one hand in the back. Excellent. Yeah, so when we made the internet, a bunch of the old guys got like the Vint Cerfs and the Doc Searles and David Weinbergers all got together and said, look, we cannot let the commercial guys or Madison Avenue or government get hold of this and drive it. This is going to be for us. This is going to democratize access to information. It's going to democratize how we create information. Everybody's going to become a publisher. We now know where that's heading, but at least we have that ability. And if we use that governing structure from the Clue Train Manifesto, we have this open, accessible way to actually share information with each other and really do tap into networked intelligence, which was the dream of people like Reid Hoffman when he first started investing in social media. I was telling these guys beforehand that Reid invested in my last company. And when he did that, he was also at the same time. So he gave me a convertible promissory note for $500,000. And the same one he gave to this dude named Mark Zuckerberg at the same time, between him and Peter Thiel. And, we went on different paths. But I've always been trying to solve for, let's make something that makes a difference. Let's try to create value. Whereas what we did with social media was a different thing. The first thing you must understand about machine learning specifically is that, and this is what I preach about everywhere I go, whether it's at Department of Defense or on Wall Street or wherever I go, it's like, this is not normal enterprise software. You can't buy it the same way. You can't implement it the same way. You can't think about it the same way. It's way more intimate, way more powerful. And especially if you make it adaptive, meaning that, and I know because Lockheed bought my last company and I spent 6 years there. And I've been to what's called the petting zoo in Palmdale, California. You know what this is. You guys know the other name for that place? Come on, you guys watch sci-fi. Where are my sci-fi people? So Area 51, Skunk Works, you can call it whatever you want, but all the weird stuff is. But they have a place at Lockheed where, depending on your security clearance, you can go and see all the things that your security clearance will allow. Now, one of the things I saw, which is now unclassified, was a scramjet-based autonomous thing that can be anywhere in the world within 4 hours, and when it arrives on station, make its own firing decisions. And I went, Skynet, Skynet, that's what this is, very dangerous. But by doctrine in the military, we do not allow that to happen, at least in the US. A human being must make that final decision in the, what we call the kill chain, before that can happen. There's lots of examples of this, which we need to borrow from the DoD and elsewhere, where we've learned about checks and balances. Did you know when you get on an aircraft today, like a 747, and you fly, and it goes to autopilot, anytime a change in course has to happen, there are 3 autopilots there. They each have different training systems. Now, they're not adaptive. They are somewhat adaptive, but with their constraints. But if they're going to make any kind of change in course, all 3 have to agree with each other. If they don't, they got to call a human. So that's an example, one of the design constructs we can bring to bear as we build these other systems.
So Richard, this actually touches on, Lauren was visiting my class today, and some of my students here are in the audience. And we talked about the relationship between our practices of holding each other responsible, whether that's morally or legally, and how those practices could extend to autonomous systems and where they might not extend. So Lauren, I'm going to ask you the question that I wrote down, but I'd like to invite you also to weigh in on that, where you see overlap. So as someone focused on the national security applications of AI, what are the key challenges and opportunities you see in integrating AI into defense systems? And if you'd like to speak a little bit about the moral and legal responsibility, please do.
Yeah, absolutely. I'm pretty optimistic on this. I would like to just stay up front. So again, hopefully no one's worried about things that go boom and robots taking over the world in the middle of the night. But previously, to the prior point made, I think it's really important to note that these systems, again, are going to be developed by militaries, by these systems, right? But a lot of them are coming from the commercial sectors. And a lot of this can be learned about how the military actually has quite a bit of leverage and ability to control the development and the application of these systems a lot more than I would say in the commercial sector. So that's something that's pretty positive there. I would say in the number of challenges that's going on right now, I'm going to keep it specific to the United States. I would say the United States is viewing AI as a game-changing emerging technology that is largely seen as something that's helpful for national security, particularly in the competition with China. And so that's where a lot of this kind of debate is ongoing right now. I would say, though, the United States has historically been really transparent about its beliefs and its approaches to AI and autonomous systems in military uses, and was one of the first organizations since 2012 to release kind of guidance on what it means to have these systems and when a human needs to be in the loop, or what kind of review systems would these AI or autonomous or learning systems would need to undergo relative to other systems. So I think it's been really effective at looking at the relative risk that these systems bring about. And I think it's really important to note, again, that this is beyond large language models, right? This incorporates things that seem as mundane as, automatic alarm systems or target recognition, or things that, again, have been in development for years and years and years. So a lot of this isn't necessarily that new when it comes to military applications. It's more of been a slow kind of evolutionary trajectory that's picked up in the last few years. So I'm pretty hopeful on these speeds, especially when it comes to looking at international norms and collaboration on artificial intelligence and expected behavior. I think states are really, apprehensive about what happens when an AI system's in control and interacts with another AI system or a human piloted system, and what that will look like. And there's a lot of research ongoing that's borrowing from the commercial sector, from commercial regulation and freedom of the seas, and other kinds of regulation from, aircraft and things like that, about how can you kind of manage behavior and start sort of common sense rules of the road that seem like low-hanging fruit, and you ask, what can these actually buy you? But there is quite a bit of benefit to looking at these really low basic things, are saying, we're not going to use AI in nuclear weapons decisions, that are quite helpful in terms of level setting with other countries and ensuring that things are more safe, more ethical, and that things don't kind of spiral out of control. Because I think the relative risk here for AI, you have accidents and other things, but I think it really gets to that level of, what is different here that you can't necessarily see that's a little bit more apparent with other systems, right? The black box nature of some of these technologies, or again, the increasing complexity and what kind of challenges that bring about to how states interact with one another, how they communicate, how they signal. So that is largely where I'm kind of both hopeful and where I think the most work needs to be done.
So you touched on this issue of transparency, and if you all read the deliberation guide in preparation for this event, it also touches on this question of whether these systems are transparent to us, can we interpret them, and what kind of problems does that pose? So I'd like to invite Richard and Damien, if you have thoughts about how we should think about these systems, given that for the most cutting edge kind of, whether they're large language models or other models, we can't trace back the path of reasoning, as it were, and understand fully the basis on which these systems generated any particular output.
Yeah. This is actually another thing that we were kind of talking about beforehand a little bit. The ability to trace and to explain its own reasoning within a system is a design choice in many cases. It does not have to necessarily be the case that these systems cannot explain themselves to you. Starting in 2015, 2016, starting in places like the Defense Advanced Research Projects Agency, the DoD writ large, but DARPA in specific, groups like SRI International, and a number of other working groups started to think about things that they started to term explainable AI. And that's about when you start to hear that term really take off in public discourse. This notion that what we need from these systems is the ability for them to very clearly state what it is they've done and why they've done it. Explainability and transparency, these questions become very difficult because when you say that you want something to be explainable or you want it to be transparent, that question of, okay, explainable and transparent to whom? Whose level of understanding does this need to be understand, or does this need to be explainable to, right? Who in this audience should be able to recognize what a decision that has been made by an artificial intelligence system, so-called, means, and to clearly be able to recognize the implications of the processes that it undertook to get there. At what level of explainability is it explainable enough? Is it transparent enough? For a lot of us, this gets into questions of things like informed consent, these questions of how do systems arrive at the decisions they make, and how much do the people who are subject to those systems need to know about that before they can meaningfully agree to have those systems impact their lives. And this gets back to a lot of the conversation that we were having over here, this question of how do these systems get trained? How do they get built? How do they get designed? What are the implications that go into them? All of these questions depend upon the values, again, the culture of the people who are doing that work. And so when we think about, let's take it outside of, again, we'll move outside of the generative AI space, move outside of large language models or, things like Midjourney. Let's take it back to things that are just like fairly complex spreadsheets and lookup tables, right? In the United States, a large number of benefits distribution systems, things for, say, welfare benefits like SNAP or TANF, or things for Social Security disability insurance, are automated systems. And the decisions that those systems make are processes that are fed through a fairly large algorithmic automated system. Very recently, within the past 4 years or so, there's been a large push to get those systems to be even more clearly understandable and explainable to the people who have to use them every single day to, get their benefits and live their lives. This push came about because a number of people had their benefits distributions shifted downwards. They got less money month on month with no change in their status or the information that they had input into those systems. And it was completely opaque to those users as to why their benefits were reduced. Those systems were deployed by state and federal government, but they were maintained by third-party vendors. And so those third-party vendors said, we don't have to tell you what's going on inside these systems. That's proprietary information. And so groups like the ACLU of Kansas sued on behalf of the benefits recipient. And after many years of fight, got a chance to take a look at the interior of these spreadsheets, which are, again, they're pretty complex Excel lookup tables. And what they found was completely meaningless to the vast majority of the benefits recipients until they started to be able to clearly delineate between which specific area of the table corresponded to which input parameter. And they found that one specific factor of lived disability experience, the needs of the disabled patient, the benefit recipient, had been weighted differently from 1 month to the next, such that its impact on the overarching math of the spreadsheet said that they would get about $1,000 less money.
I think we see this kind of thing happen in lots of different applications. So thank you for that specific case study. I want to, in the interest of time, move us on to Richard's kind of central question, and I'll focus it around entrepreneurship, but it sounds like there may be other things that you want to weigh in on here. So with your experience in tech, entrepreneurship, and AI, which industries do you envision AI transforming the most, and how, if you had to make a prediction?
Well, if elected, what I will, I'm sorry. No, there's again, lots of issues here. The example you just gave, Damien, was one of what I would still call the old AI. It's algorithms which are can be transparent to inquiry if we just let them be. But like your credit rating and a lot of these algorithmic decision-making systems are human designed, but they're very, very complex. And that's one issue that we're all wrestling with right now. And I approach it this way, and this goes across every area of human endeavor, which is complexity is only going in one direction. Last I looked, right? We human beings are creating systems so complex, we don't understand how they work, much less have any hope for managing them. My little joke there is we humans haven't had an upgrade since, anybody? Pleistocene, right? So I thought that was really funny. But anyway, so that's the last time but these systems we're playing with now are upgrading really, really quickly. It's one thing to have these large algorithmic sort of decision-making systems we're employing in our financial systems, and we're adding automation to those old systems. That's how you got like the flash crash and a lot of the things that we're seeing out there right now. But when you add machine learning to it, it goes to a whole nother, it's geometrically at least more complex. If not exponentially more complex. And the issue, like I've been trying to say with machine learning specifically, is when you have these massive data sets and you're feeding it into a system and it's adaptively determining its own weights of everything within the system that it's building, there is no debugger. And that was the first shocker to all of us software developers, is like, you can't debug the system. There is not a debugger. And how many software developers do we have? How do you work on a system or fix a system that can't be debugged, right? And that's the problem. Also, but the good news is these systems cannot transcend their databases. So whatever it is they were trained on, like ChatGPT is really a lossy compression of the internet. And that creates other problems. So the good thing is it can't transcend its database. It's never going to create anything new or crazy out of it or creative. But the big problem with that, and I've already seen that I created my last machine learning company in 2014. So during that time, in short periods of systems I built at research institutions, at banks, and elsewhere, we have seen this thing called model collapse. Have any of you heard of that? That's a very real concern there too. And you will see it with ChatGPT and other systems. Because when they start feeding back in, like you're already a lossy compression. I mean, you've lost data. Hopefully what you lost isn't important. Now you train on that stuff as your next round of inputs, and it keeps going. Eventually you have what's called a massive forgetting. And who's to decide what's important and what isn't? Because no human can get in there and track it. It's just we're not capable. So to get to your question, the fundamental rule that I have here is that there are certain areas of human endeavor, because of increasing complexity, where being a standalone human being is insufficient. That's just where we are. I'm sorry. Like, you need to have some kind of system that can help you make better decisions at a tempo. I've got lots of examples of that. The oldest example that I learned about at Lockheed is when we switched from propeller aircraft to jet engines. A lot of people died. I mean, we don't think about it now, but jets were going into the ground like darts. And it's because the pilot said, I am the master of the cockpit. I have to understand all the inputs and outputs. I must control everything. It's like, you just can't. The human brain, again, hasn't had an upgrade since when? So you can't deal with the tempo of the inputs and outputs. So what you have to learn to do is start outsourcing portions of that flight envelope to systems that you can trust. And that's the big thing here. We're going to talk about trust a lot. Hopefully you will in the next hour. Trust with a capital T is the big issue. How do we build systems that we can trust outsourcing to? The way, like when I first learned to drive, you had to pump the brakes to stop it when it was wet, right? Now we trust anti-lock braking, right? We trust all kinds of little mini systems that do things for us. We trust our GPS to get us here, to the point where some people drive off bridges and drive into buildings, and because we're trusting. But so some areas I think really need this. Healthcare. We are killing 190,000 people a year in this country alone unnecessarily with things like what we did in that example I just gave you. Is we engineered human error out of the system with safety interlocks and checklists and prognostic maintenance and simulation and system of systems engineering, and now automation like AI and autopilots. We need to be doing the same thing in healthcare. It is not reasonable for you to go to the doctor and say, like, I have all these symptoms, and for your doctor to do this and go, well, I think it might be this. Like, what the hell are you looking at? Why aren't you looking into the computer and looking at a massive set of information? And maybe there's a lot of different machine learning models that are looking at the people like you algorithm, the same algorithm that does your credit rating and the stuff you were talking about with SNAP and those things. But it's determining, like, here's the most likely distribution of things that are likely wrong with you. And now here are the things we can start digging into. That, I think, is critical right now, and we're not doing it fast enough. That's just one.
I think Damien's got a follow-up.
I do. So that question of trust is, I think, crucial in this space, but it also kind of undergirds my go-to word of the evening, values, right? The question of how we trust what we trust, of how we determine what is trustworthy, is crucial to that question of, can these systems be trustworthy? Well, what do we mean by trustworthiness? In what situations, in what contexts, in what circumstances are we meaning trustworthy? Because, yes, as you mentioned, people have driven off of bridges or driven into walls or driven into ditches. People have died because they followed their GPS too closely, even absent, in defiance of the evidence of their own eyes. That question of a system being trusted over and above the human experience is a real potential problem, especially when that system is given the imprimatur of its mathematics. And so it is infallible. It is code. And so it is unbiased, right? That has been used over and over again to say, these systems can be trusted. These systems ought to be trusted because they, by their very nature, remove the downsides of humanness. But they don't, by their very nature, do that. They only do that if we, the humans, do it. That means that we have to figure out how to mitigate, not remove, mitigate our biases, mitigate our perspectives, to ask questions, and then to teach these systems how to do that same thing. That process that you're talking about of those multiple different databases that we use, those multiple different algorithms that we use to check and recheck, we have to figure out a way to teach these systems to do that within themselves. Because the biases that are already at play in those systems mean that when my doctor consults that database, they're going to give me, for the same range of symptoms, a very different output than they're going to give you. And the main factor that's going to be the difference isn't our age, it isn't our relative health, it's our ethnicity and our race. And that happens constantly with the medical systems as they currently exist, with the automated medical systems as they exist. And that is a huge deal both in the application of medicine itself, but it's also a huge deal in terms of when insurance determinations get made and what gets said could be paid for
based on whose risk factors are higher and their likelihood of survivability of the procedure. Who even gets the access to the medicine to begin with? So we have to figure out how to make the systems trustworthy and then use them to help us figure out what we mean by trust.
I mean, in a similar kind of vein, I think a lot of, at least in my sphere, especially when you get into conversations about lethal autonomous weapon systems again and killer robots, and how do you control for that, and how do you mitigate some of the harms of that? A lot of the catch-all solution is to put a human in the loop, or exert positive human control or meaningful human control, whatever, baggage-laden term you want to include there. But again, humans have been proven not to be super effective monitors of these systems, right? Their propensity for automation bias, right? You see the case with the Tesla recalls. They've blamed it on the system and the software, but it's really the human monitoring, right? They say that the software hasn't made it evident enough to the human. The human, they can't really regulate the driver whether or not they're going to pay attention, no matter how bright they make the flashing lights in the system, right? But that's resulted in them, recalling, all of these cars. And so I think the question becomes, again, not necessarily, I think there's a lot of focus in the governance aspect about the systems themselves and the risks inherent to the systems themselves, or on the reverse about the human users. But I think it's really important to look at this interaction point about how these systems and users interact and in the problem space that they're interacting. And I think that's going to be more challenging. But at the same time, I think that, if you break it up by application or by sector, hopefully all these kinds of regulatory frameworks and the kind of authorities and organizations that already have the kind of purview to regulate these systems do have at least some of the requirements to already kind of get started on those issues.
So
Go ahead.
I mean, I have a solution to all that I've been thinking about for a very long time. If I can I'll try to do it really quickly. All right. So again, I think there's so much infatuation with ChatGPT, large language models today, and I'm listening to all that. Very amused by it. I think there's lots of other pieces of the puzzle we're putting together. But when it comes to trust and things like that and testing systems, one of the things I learned in my tenure running virtual world labs at Lockheed Martin is the value of simulators, of simulation. So, and unfortunately, my friend Doug Lynette just passed recently, but if you look up a project he's had since 1984 called CYC, C-Y-C, he connected a knowledge graph to a reasoner, and now he's connected a natural language processing system, and it does explain itself now. I'm not sure how he's doing that, but it's amazing. But the triumvirate that I think is going to be the most valuable to all of us, and also maybe give us the greatest peril, is this triumvirate of the knowledge graph, which is part of that old AI stuff. How do you really determine and weight knowledge ontologies, like what's true, what's verified? And then you have a large language model, which just serves as an interface to that and lets you do natural interrogation of that knowledge graph. But man, don't forget your knowledge graph. The first thing I did when pandemic started is I built a big COVID knowledge graph. And that's the first thing I did, and tried to determine what is true. And I was telling these guys about it before this session started. Longer conversation, but it was hard, but we did it. Then the last piece is a simulator. So if you go and look at a lot of the systems that learn to play Atari and Go and chess and that kind of thing, one of the interesting things about neural nets, now we're getting into a different depth here, but neural nets, when you give them a problem like just here's the rules for how to play the game Othello or Go or whatever, even if that's all you give it, what they'll end up doing is trying to construct for themselves a visual or a simulation of the board. And then they'll start using their system to adapt and learn. So if we put all those three things together, I believe that's how you're going to get artificial general intelligence, by the way. And then the last thing, I know we're at time, but in terms of trust, if we had a simulation of everything, and then you could test these systems in there before we release it on the world, that would be my safeguard, like keep it in a little pool or its own little safe room first. And that's one of the things we did at Lockheed with all the systems we built.
It sounds like we're about to wrap up here, but it sounds to me like one of the themes that has emerged tonight, a point of agreement, has been that in order for us to understand the impact that we want AI to have and that we want to mitigate, we need to understand ourselves. We need to understand where we are good at monitoring these systems, where we are biased, what our own kind of potential is. So I'd like to thank our panelists today, Richard, Lauren, and Davian, for modeling for us how we can have a kind of productive conversation about AI where all kinds of experts and the public disagree about this. So thank you so much. And I'd like to invite you all to give our panelists thank you as well.